Good morning, students. I am going to teach you the subject design and analysis of algorithm. For this subject, the course code is CSE 502. And for this course, I will follow the book Introduction to Algorithm by Foreman, and second book Algorithm Design by Kleinborg. Now, before starting of the course, we have to know what is the course is and what is the importance of the course. The course name is Design and Analysis of Algorithm. Hence, first time, what is algorithm? As you have already acquainted with the many algorithms in your data structure, in your architecture, and also other subjects. And in algorithm, algorithm is sequential of steps to solve a particular problem. Now, in the problem, the statements, the problem, there will be certain specification that what is the problem and what is the input and what the output the problem wants. But the problem never say how to get that output from taking the input. And the algorithm is the solution of the problem, and hence algorithm is well-defined computational procedure that takes some values or set of values as input and produces some values or set of values as output. Hence, the algorithm describes a specific computational procedure for accomplishing the input-output relationship. This is the algorithm, and in your data structure you have studied many algorithms, right? Like your tree algorithms, your tree insertion, tree deletion, and your different graph searching or sorting algorithms you have also known. And in that case, the problem is given, the input is also known, the constant is also known, what the output is required is also known, but how to solve this? That things how to solve is nothing but the algorithm. And in the course, we will study theoretically the designing of algorithm, that how we will write the algorithms, design the algorithms, and analyze the algorithm, whether it is a good algorithm or a bad algorithm, and what amount of resources that algorithm will take for solving for solving any kind of problem by the help of computer. Hence, the design and analysis of algorithm is a theoretical study of design and analysis of computer algorithm. Now, any problem, computer problem that is solved by the computer have followed different steps. First, it will be a problem. First, the problem will be given. Now, in the problem, what happens? There will be some kind of specification. In the problem, there will be some statements of the problem. Statement, what type of input the problem will take, what the output the problem will wants, and what are the properties or constraints associated with the problem. That problem is given. Now, you have to know the problem, so you have to analyze the problem, and you have to know the properties of the problem. Now, after knowing the properties of the problem, that means you are analyzing the problem. Remember that analyzing the problem is different than analyzing the algorithm. Problem analysis is something different, but algorithm analysis is something different. Once you have analyzed the problem, you have understood the problem. Once you have understood the problem, what will happen? You have to write steps, what are the steps, sequential steps to solve the problem. These sequential steps to solve the problem is nothing but your algorithm. And once you have written the algorithm, that doesn't mean it will directly run in your computer. Algorithm can be any language, maybe pseudocode language, maybe your any programming language, or maybe simply written English written language. This is the algorithm. And for running in the computer, you have to translate the algorithm into programming language. Suppose you have written an algorithm and you want to run in a computer, and you may write the algorithm into program, say maybe in C program, maybe Java program. And that in converting algorithm into program is called implementation part. Once you have implemented your program, then you will compile and execute the problem in the computer. This is the problem solving process in computer. Now from this, one thing is that algorithm. As it is mentioned here, in algorithm. After knowing the analysis of the problem, you will write the algorithm. And in that algorithm, writing the algorithm is called designing the algorithm. Suppose you have written an algorithm and your friend has written another algorithm for solving the same problem. Now the question is that whose algorithm is good? Whether your algorithm is good, whether your algorithm is good, or your friend's algorithm is good. Then to compare these, which one is good, which one is the best, or which one is the better, to compare, there will be certain parameters that should be taken into consideration while we are analyzing your algorithm with your friend's algorithm, and or comparing your algorithm with your friend's algorithm. That or evaluating your algorithm, how your algorithm is, that is called analysis of algorithm. And hence, in this course, we will discuss how to write the algorithm for a particular problem, what are the different way of writing the algorithm, and evaluating or analyzing how better your algorithm is. Now the question is that what is the better, how will you know that which one is better? Because in that time we will say how much time your algorithm will take, how much resources your algorithm will take. That is called analysis of algorithm. And other factor of the algorithms, whether it is terminating properly, whether it's maintaining, the algorithm is maintaining properly or not, some parameters that we have to see while we are analyzing the algorithm. And the course is design the algorithm and also analyze the algorithm. Hence, throughout the course, we will discuss how to write the algorithm and how to analyze the algorithm, and what are the different way of designing algorithms. This is the course objective. Now the question is that what are the practical examples that the algorithm is used? There are everywhere where we are using the computer to solve a problem. There the concept of algorithm is coming. Let us take an example as it is shown, internet and networking. See, internet and networking, how the algorithms helps us. See, in the internet, suppose you want to get a data. The data is somewhere in the server and the data has to reach you. It will follow different paths. And there are follow different paths, and there are many number of possible paths that the data has to travel to reach you. Now, in order to you get the data quickly, not only your internet speed is necessary or your connectivity is necessary, but also the way that data travels, the path that data follows is also required. Suppose your data is traveling with a long path, then it will take a long time. Whatever may be your processing or internet speed. Hence, for that, what happens? You want to design all the algorithms so that out of the different paths, how the shortest path or shortest route, the data traversal will happen. That is the concern in the internet or network. Hence, while you are designing the internet networking, that means best route, how the data will follow the best route. For that, you have to write. For that, you have to design some procedure. That is nothing but algorithm. Another thing is that, suppose you want to data, before locating where is the data, first of all, you have to locate where is the data. That means you have to source the data. That means if to source, you have to follow certain procedures. Now, which procedure is good to search the data over the internet? That is called searching algorithm. Searching algorithm. Hence, in the networking, the search algorithm, also which one is the best searching algorithm, and different searching algorithms are also employed. Okay. Hence, in the networking, the algorithm is also required. Another example is in e-commerce. In e-commerce company, as you have known, in electronics commerce, they keep the user information in their site. Suppose you are buying something from the Amazon, the next time while you are going to buy, you will see in your mobile automatically they have saved your credit card information, your bank account details, everything. Now the question is that while they are storing these things, they must store in such a way that the other person cannot get it, because it is your personal information. Hence, the storing must be private and safe and secure. Hence, for that, they require some encryption and decryption method. How they will encrypt and store it is required. Hence, your e-commerce company will use some algorithm that is called encryption or decryption algorithm to save your data privately. Another thing is also that the electronic commerce also use, while they are selling their product, they want to make the profit. Then how will they make it profit? Depending on the demand of their product, they can increase the price, or they can, depending on the less demand product, they may give certain kind of discount. How they will know? Because they have to write some program or some algorithm, they will follow some algorithm to know which product is demand and which product is giving discount, they will attract the customers. That means they are following some kind of algorithm to do that. Hence, these are the two examples where the algorithm is used. But there are other scenarios where algorithms is very much essential. In case of your architecture, while you are executing the instructions, there you are also following certain algorithms. How the instruction will be arranged in such a that there will be no hazards, as you have already known in your architecture class, there will be no hazards, and there will be overlapping execution will happen. That is your Thomas Schultz algorithms. Or how the data hazard or the structural hazard, there are some basic core algorithms for the computer science. But for the students who are not computer science, in order to know where the algorithm is used, these are the some examples. Now the question is, why algorithm instead of program? Now the question is that, why we are going to write an algorithm? We can directly write a program. Remember that if you can write a program instead of write, but the problem is that if you are writing the way of solving in directly in the program, then it will be difficult to understand. Because writing algorithm is simple, because it no need any programming syntax, and also understanding the algorithm is easier than understanding the program. That's why first of all, before writing the program or before implementing, we have to write the algorithm because it is simple to write and easy to understand. Now, then which language I will use to write a program? You can write, to write an algorithm. Any language of your own, maybe English, Hindi, you can use step by step to write the algorithm. Or you can use a pseudocode language, pseudocode to write an algorithm. Or you can write a graphical representation, you can represent graphically to represent an algorithm. Now the question is, graphically it is fine, what is your own language by step is fine, but what is pseudocode? Pseudocode means it is not directly the program, but program oriented writing of program or towards program oriented writing of algorithm is called pseudocode. Not full code, rather the syntax will not follow, rather it will a program oriented way of writing may not follow the exact syntax of the program. It is called pseudocode. Now, what is analysis of an algorithm? As I have already told, predict the cost of an algorithm in terms of resource and performance is called analysis of algorithm. Suppose you have written an algorithm, or there are some algorithm are there. Now, while you are writing the program, before writing the program or for the algorithm, you have to analyze the algorithm. How much resources the algorithm will take. Resource means how much time it will take to run the program in terms of the input. That means whether how many seconds it will take and how many memory it will also consume. How many memory or the memory or the it will require. Hence, to analyze the algorithm to predict the cost the algorithm will need in terms of resource and performance. Performance means how much time, resource means how much memory that the algorithm is required to run in the computer. And sometimes, what is design of and sometimes along with the performance, we also study in the algorithm modularity, correctness, maintainability, functionality, robustness. These things also taken care. Now, all these things we will discuss later while we will discuss about a specific algorithm. Now, why I have said two things. One is the design an algorithm, and second thing is analysis of algorithm. And now, while we are analyzing the algorithm, what are the different models that is used to analyze the algorithm? See, in the computation, that two model in the designing analysis of algorithm, there are two models we can follow. One is the Turing machine model. In your automata theory, you will study that Turing machine is a kind of automata, though there are different kind of automata, that is your finite automata and a push down automata and your Turing machine. These are the some model of computation, theoretical model of computation. Out of that, Turing machine is one model, and in this Turing machine, there are they are represented by the states, as in this case R, L, H are the states, and they will take the Turing machine will take some inputs and it will produce some output. At the same time, it can move from one state to other state by consuming or taking an input and produce some output. Output is where? Output in the cell, in the tape cell. In the below there are the cells are tape cells are there. The square boxes, these are tape cells. Now, in this Turing machine model, while we are analyzing the analysis, the algorithm analysis can be done by using Turing machine model. Now, in that case, how much time that a Turing machine will take, it depends on how many number of steps that the steps required to solve the algorithm that will be taken. That means, suppose it will start from the initial state and it will take the input provided to the algorithm and it is going to the halting state or the final state. At that time, how many steps that your Turing machine jumps from one state to other state. Here the circle is the state, and how many steps that how many jumps from one state to other state are there, that is considered as the running time. And memory, how much memory your algorithm will take is the number of tape cells that the utilized, and where the output will be stored, the output will be stored in the what is your a tape cell. The output will be stored in the tape cell. This is one model of computation that is called Turing machine model. Hence, while you are analyzing the algorithm, you can follow the Turing machine model of analyzing the algorithm. And in your automata theory, this semester, the course automata theory is running, and there you will know what are the different type of model of computation. And out of that, there are one model is Turing machine model. Okay, but here in automata theory, you will study three type of model. Out of that, there is one Turing machine model, and we have to, in order to analyze the algorithm, you can follow the Turing machine model. Now, next one is word RAM model. That means analyzing the algorithm, we can follow RAM model of computation. Though it is not a computational model in your Turing machine, not thing. Here in the computational model, while we are analyzing the algorithm, how we will study? Here, see, there is a program, there is an input, and there is an output. You see the figure, program is there, or the algorithm is there, input will be there, output will be there, along with it will take some memory. Now, each memory locations, in the memory, each square box stores W bit of bit integer, W bit of integer. Now, the primitive operations in this case is your, what is arithmetic logic operation, because in the program or the algorithm there will be arithmetic logic operations, read-write operations, array indexing, conditional matching, all these primitive operations is assumed to take 1 unit of time. Hence, how many number of primitive operations that your algorithms follows to solve the problem, taking the input from the input take and providing the output to the output state, is how much this number of primitive operations has taken is nothing but the time. That suppose it takes n 5 primitive operations, then the time is 5 unit of time. Suppose it is taking n square number of primitive operations, for where n is the input size, then in that case we will say that the time it will take is the n square time. This is the running time of the algorithm. In case of RAM model, will be considered as the number of primitive operations that your algorithm has to follow. Now, in that case, how will you say that how much memory that the algorithm or program utilizes? Program is utilizing. In that case, it will say how much of memory cells that your algorithm or program is utilizing or using is the what is memory requirement. How much memory cells? Suppose it is taking a 2n memory cells, then your space requirement or your memory requirement for the algorithm is 2n. This is the situation. Hence, while we are analyzing the algorithm, you can follow the Turing machine model of a computation, or you can follow the RAM model of a computation. But through the course, we will generally follow the RAM model of computations. Sometimes we will, in the last unit, we will follow the Turing machine model of computations to analyze the algorithm. Okay. Now the question is that what is space and time complexity? Then while we are analyzing the algorithm, a term is coming, what is space and complexity and what is time complexity. Now, as I have told, analysis of algorithm is finding how much, what is the performance in terms of time, and how much memory space it is required. Now, the space complexity of the algorithm or a computer program is the amount of memory space required to solve an instant of the computational problem. As a function of characteristics of the input. See, what is space complexity saying? It is nothing but amount of memory space required to solve a particular problem in terms of function of the in terms of the characteristic of the input. That is the space complexity. Space complexity of an algorithm means how much amount of memory that your algorithm require in terms of the input size. That means, hence, in case of your Turing machine model, how much of your tape cell utilized, or how much tape cells your algorithm is using, that is called your space complexity of the algorithm. Space complexity of the algorithm in case of Turing machine. But in case of RAM model, it is the how much memory cells utilized. You remember the RAM model? There is the memory cells. Now, how much memory cells that your RAM model is using while running the particular algorithm or program is called the space complexity of that algorithm or program. Hence, in the case of Turing machine model, the tape cells utilized is considered as the space complexity of that particular algorithm. Whereas in case of RAM model, it is the number of memory cells used, which is considered the space and complexity of the algorithm. And similarly, the time complexity means it is also called as computational complexity, and it is the amount of computer time it requires to run an algorithm. That means, suppose you have an algorithm and you have written correct program for that algorithm, or you have written a program following that algorithm, and you are running the algorithm. And in the running algorithm, starting from the running of the algorithm to giving at the end, providing the correct output, how much computer time it requires. That is nothing but the computational complexity or the time complexity of the algorithm. Now, in case of RAM model, the time complexity of a particular algorithm is calculated by using how much primitive operations that the RAM model follows if it will be implement the algorithm. But in case of Turing machine model, how many number of steps the algorithm jump from one state of the Turing machine to other state in order to reach to the final destination or the accepting state is called the time complexity of the is called the time complexity of the algorithm. Hence, in case of RAM model, it is the number of primitive operation required for measuring the time complexity. But in case of Turing machine model, how many jumps from one state to other state? What are the number of jumps from one state to other state? That the algorithm, your algorithm is doing is called the time complexity for the Turing machine model. Whatever may be, but both the model are more or less equivalent. But the analysis, either you follow the RAM model or you follow the Turing machine model, they are more or less same. Now, in the next class, we will discuss about asymptotic notation.